Greetings to you. Welcome to Physics with Ben. Don't forget to subscribe and share this video to those that need it. As promised, I have come to plot the graph for the experiment we did on knife edge, the experiment to verify the principle of moment. In this experiment, we are meant to find the mass of the ruler using the principle of moment. So click in the description box below, you will see the video link for the real experiments. These are the values we generated in the table, in the experiment. These are our table of values. The parameters in the experiment, or the variable, m, x, and x inverse. So without wasting much time, we are asked to plot a graph. We're asked to plot a graph of m on the vertical axis. Plot a graph of m on the vertical axis and 1 over x on the horizontal axis. This is the graph we are asked to plot, the graph of m against x inverse. As predicted yesterday, I told us in this video, in the video for the experiment, that such a graph will give us any of 1, 2, 3. So let's see how it goes. So the first things first we are going to do is to find the scale for the graph. For this, on the horizontal, on the vertical axis, the highest value here is 150 grams. So we are going to choose a scale in such a way that it will contain everything here. So this is a WAEC standard graph. I have told us in other videos how this graph is used. This graph is segmented to 2 cm. 1 cm means 5 small boxes. So 2 cm stands for 10 small boxes. If you count, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From this point to this point is 2 cm. So let's try. Can we say 2 cm to present 20 units? Let's see. This is 20, 40, 60, 80, 100, 120, 140, 160, 150 halfway. So it means that 20 cm to 2 units is good. Yes, 20 cm to 20 cm to 2 units is good. So we're going to write here on the y-axis, this is the x-axis. On the y-axis, we can say that 2 cm to represent 20 units. That's it. So we're able to occupy this value with that. Then on the x-axis, which is this value, the highest value here is 0.385. Can we say 0.01? We have 1, 2, 3, 4, 5, 6. Let's try it. 0.01 times 1, 2, 3, 4, 5, 6 times 6. Okay, that is 0.06, far away from that. So can we say 0.02? Okay, let's go 0.01. So this is 0.02 cm to 0.01. So 0.01 plus 0.01 will give us 0.02. So this is 0.01, 0.02, 0.03. Okay, can we say 4 cm to 0.02? 0.01, sorry. So 0.01, 0.02, 0.03. So we say 4 cm to 0.01. 0.01 plus 0.01 will give us 0.02 plus 0.01 will give us 0.03 plus 0. So we go with this scale that 4 cm to 0.01. So right on the x-axis we say 4 cm to 0.01 units. That is 4 cm simply means 2 cm means 20 small boxes, and 2 cm means 10 small boxes, while 4 cm means 20 small boxes. That is what it means. So we are going to shift this line up here. We said that 2 cm to represent 20 units on the horizontal vertical axis. So this is 20, 40, 60, 80, 100, 120, 140, 160. So we're going to draw a horizontal line here on these points. We draw a horizontal line here. Don't forget that your slope is another very, very important part of your experiment. We'll put an arrow here, and this is our x inverse slash cm inverse. And then here we're gonna say draw this line up here. Yeah, so this is our m slash gram. Yeah, something like this. I hope we are following. Yeah, so every physics graph will start from the origin. So this is 0, 0. That's the origin. Now we will say 2 cm to 20 units. This is 20. Each 2 cm will be adding 20, 20. So this 20 plus 20 will give us 40. The next one is 60. The next one is 80. The next one is 100. The next one is 120. The next one is 140. The next one is 160. That's it, all in grams. So we are done entering these values here. Don't be tempted to start with 50 as a first thought. You know that 50 is somewhere in between here. So on the horizontal axis, this is 4 cm, this is 4 cm, this is 4 cm, another 4 cm. So we said 0.02, right? So the first 0.01. So this is 0.01. 0.01 plus 0.01 will have 0.02. Here we have 0.03. Here we have 0.04. That's it. So this is how your graph will look like. Something like this. You may screenshot. Good. So the next thing is to find the value for each small box on the horizontal axis on the x-axis. So 20 cm divided by 10. 2 cm simply means 10 small boxes. So this 20 by 10 will give us the value for each small box. So say 20 divided by 10, that will give us 2. So on the vertical axis, we say that 20 by 10, that will give us 2. So the value for each small box here is 2 cm. On the horizontal axis, we say 0.01 divided by, this is 10, this is 20, divided by 20. That will give us 0.0005. That is 0.01 divided by 20. That will give us 0.0005. This is the value for each small box on the horizontal axis. Now, This makes it very easy to plot graphs of this nature. These are the most dangerous graphs to plot in physics. So we are going to divide everything. We are going to divide everything here by 0.0005 cm. When we do that, we are going to find the value. We are going to find, when we divide everything here by 0.0005, we're going to have the result. What we have as a result or as the answer is simply the number of small boxes we have to count to get these figures on the horizontal axis. So let's start with the first one. When the gram was 50, 50 is halfway in between 40 and 60. So this is 10, 20, 25 will give us 50. So 2 times 25 will give us 50. So this is 10, 20. Let's count 5. 1, 2, 3, 4, 5. This is where your 50 is. Your 50 is somewhere here. So when the mass was 50, what was x inverse? X inverse was 0.026. How can we get this value exactly on the graph? So we say that 0.026 divided by the value for each small box, that is 0.0005, and that will give us 52. It means that we have to count 52 small boxes on the horizontal axis before we are going to get this value, this particular value here. So let's count. This is 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. We count 2 more. 10, 20, 30, 40, 50. 1, 2. This is 52. Good. So we are going to trace this line. We trace this line straight up. Where this line meets with 50, that is where the point is. This is the point. So this is where the 2 lines intersect. We draw something like this. We are done with that point. So we are going to do the second one. Which is when it was 70, it was 0.028. So where is 70? 70 is halfway between 80 and 60. So let's count. This is 10, 20, 30, 35 will give us 70. So this is 1, 2, 3, 4, 5. This is where 70 is. So when it was 70, it was 0.028. So we say 0.028 divided by the value for each small box, which is 0.0005. That will give us 56. It means we are going to count 56 small boxes this time. So this is 10, 20, 30, 40, 50. 1, 2, 3, 4, 5, 6. This is 56. This point. So we trace this point. 10, 20, 30, 40, 50. 1, 2, 3, 4, 5, 6. This point straight up. Where this point intersects with this line with 70. That's it. This is the point. So this is the point. There's the point. So we're going to do the same thing for all the values. Let me take it up so that you see what I'm doing. Good. And so we are done with the table of values. I did it the way I was telling you. So this point, let me take it very close. This is your table. This is your graph. we are done with the graph. Just look at it. This graph is exactly what I predicted. Do you remember? I predicted something like this. And obviously, we are going to plot graph 3. Just that the line does not extend down here. But this is the graph we are going to plot right now. So the next line of action is to draw the line of best fit. Put our ruler and draw this line. I always advise that we make use of the transparent ruler. We have catched this point, we have touched this point, we have touched this point. This is a very perfect graph. Almost all the points are touched. So if we can extend it, so we draw this line from here, straight down. Yeah, this is the point. If we extend this line down, maybe we would have shifted it up a little bit. You'd observe that it is exactly this graph 3 I predicted, having intercept on the x-axis and on the negative y-axis with the equation this. So the next thing is to draw our large triangle and to calculate for the slope. So we are going to choose this point. We choose this point, this both line. We choose this point, and then we choose this point. So we draw a straight line here, and then we draw another line here. We draw this line here, and then put a dot, and this is our x inverse 2. We put another dot, and this is our x inverse 1. Then the same thing here. We trace this line here. Replicate what I'm doing in your book. Exactly what I'm doing in your book. Dot, so that I'm able to read it correctly. And this is your M2. Then this line, this bold line, dot, and this is your M1. So here is your change in M, and here is your change in x inverse. Something like this. Lovely. The next thing is to calculate for the slope. So our slope for this is equals to change. Slope is change in m divided by change in x inverse. The same thing as m2 minus m1 divided by x inverse 2 minus x inverse 1. If you do that correctly, our x inverse 1 is on this point. So how we read it? This is where the value for each small box will have to play another role again. So say 0.0005 times, let's count. This is 10, 20, 30, 40, 50, 60, 70 times 70. And the value here is exactly, okay, let's do the up one first. The up one is 2. So say 2 times 10, 20, 30, 40, 50, 60, 61, 62 times 62. That will give us 124. That's our M2. Our M1 is simply 20 divided by x2 inverse. So 0.0005 times 10, 20, 30, 40, 50, 60, 70 times 70. That will give us 0.035 minus 0.0005 times x inverse 1 now. So this is 10, 20, 30, 40. 1, 2, 3, 4 times 44 times 44. That will give us 0.022. 0.022. If you do that correctly, you have 0.20. We have here we have 104, 124 minus 20. You have 104. 104 divided by 0.035 minus 0.022. That will give us 0.013. So we have 104 divided by 0.013. We have 8,000 as our graph. The unit is gram. Gram divided by cm inverse. If you take it up, you're going to have 8,000 gram cm. 8,000 grams cm. So this is your slope. So that is supposed to be calculated. Exactly what you see me doing here. So you can screenshot this, your graph. The next thing we're going to look at is deduction. So our deduction, they ask us to state 2 precautions. In this experiment, there are 3 basic precautions you have to give. There are 3 basic precautions that we have, but you have to state just 2. Precautions carries 2 marks. So one precaution is that I avoided error due to parallax when taking reading on the meter rule. Number 2, I ensured the masses were not touching the table. If you remember yesterday, we were balancing this ruler and the masses were not touching the table. Yes, so you ensure that the masses don't touch the table. Yes, they don't touch the table. They oscillate freely like this. That's one precaution. That's number 2. Number 3 precaution is that I avoided air interference by closing all the air source, by offing all the fans in the lab. Good. Don't just say I avoided air interference. You must say what you did to avoid the air interference. Number 1, I avoided error due to parallax when taking reading on the meter rule. Error due to parallax are error due to the usage of apparatus in experiments. Number 2, I ensured the masses were not touching the table. Number 3, I avoided air interference by closing all the air source. So we have done precaution. Number 2 is they ask us to find, that is BI. BI carries 2 marks. We also have BII, also 2 marks. BI and BI will give 4 marks. So BI said, using your graph, determine the value for x for which m is equal to 0. This is where m and x are equal to 0. So when m was 0, this is the point. What was the value of x? The value of x for this particular point here. So, but here we have x in there. So we say that m equals to 0. So when m equals to 0, x inverse is equal to what? This value here. When m equals to 0, x inverse was this value here. That's probably the intercept. So let's check. We have 0.0005 times 10, 20, 30, 40. This is 10, 20, 30, 38. 39, times 39. That will give us 0.0195. But we are not looking for this. So this simply means 1 all over x is equals to 0.0195. This is all over 1. If you cross multiply, we have x is equals to x times 0.0195 is equals to 1. So we have x times 0.0195 is equals to 1. To find x, we divide both sides. 1 divided by 0.0195 divide 0.0195. This go. So this implies that our x is equal to 1 over this figure. So 1 divided by that will give us 51.28 cm. So the value for x is 51.28 cm. So the second deduction is we should that's BII. BI says state 2 conditions necessary to maintain the initial rule in the experiment above. There are 2 conditions here. Condition number 1, the clockwise moment must be equal to the anti-clockwise moment. That's condition number 1. Number 2, the upward force must be equal to the downward forces. We call it parallel coplanar forces. Those are the basic conditions. BII, that is BIII, says using your graph, determine the value for x for which m is 100 grams. So this is 100 grams. We trace this value here where this hits our line, our graph. This is the point it hit it. We trace this point down and that becomes the value for x. So we trace this value and we get this. We get this. So let's count. We say that 0.0005 times this value. So this is 10, 20, 30, 40, 50, 60. 1, 2, 3, 4 times 64 times 64. We have that. So when m was 100 grams, x inverse was equals to 0.032. So, but we are not looking for x inverse. So it means that our x is simply 1 divided by 0.032. If you do that correctly, you have 1 divided by that, and so we have 31.25 cm. So when m was, we call all this deduction, when m was 100 grams, x inverse was 0.032, and if you reciprocate that, you're going to have 31.25 cm. So that is the deduction. Don't forget, we trace 100. It hits the graph at this point, and then we trace it down, and then we got this figure 0.0005 times the number of sponsor boxes up to this point. We got this, and then we find the reciprocity of this. To this, we have come to the end of this experiment. So this year's WAEC mechanics expects the 2 experiments I have performed on knife edge. That is the principle of moment. The first one was to find the mass of the unknown. This one is to find the mass of the ruler. Quickly, the examiners did not ask us to find the mass of the ruler in the experiment, but in case you want to find the mass of the ruler, this is very, 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 very simple. Let me just teach you what to do. The ruler, the center of gravity of the ruler is at the 50 cm mark. If you place it horizontally, that's where it balance without masses. So you keep moving this, until when it balances. Then you do something, which I'll teach you right now. It is balanced. So what do we do? This is 27 minus 1. That will give you what? 27 minus 1, that will give you so in this case our x is equals to 28. This is 150. Our mass is what? 150. So say 150 times 28 is equals to 50, the weight of the ruler. So 50 minus 27. 50 from 50 to 27 is what we are dealing with. So 50 minus 27. 50 minus 27 will give you 23. So we say W times 23. So we say that W is equals to 150 times 28 divided by 23. This is a simple equation that will give you the mass of the ruler. To this, we have come to the end of this video. God bless you. Bye-bye.